Hello, welcome to a new video in this microservices series. In previous videos, we talked about containers, the difference between a container and a virtual machine. As a developer, how can I use container for building and packaging my application? And as a DevOps engineer, how to set up a pipeline for continuous integration and continuous deployment using containers. In this video, we will talk about Kubernetes. Kubernetes is a little bit more complex topic than Docker. So let's start exploring why do we need Kubernetes and why is it useful? As we know, we use Docker to build a container image and deploy it on one machine or one server. With Kubernetes, the need comes when I have a server farm that has tens and hundreds of servers, and I want to manage these servers. I want to manage the resources on these servers, and I want to distribute or deploy my application on these servers. I want to monitor the servers for if they have low resources, I need to move application from one to another. If one of the servers down, I need to redistribute the applications on that server to the others. I need to be able to tell Kubernetes, please deploy my application on 5 instances, and he will decide which servers have the capacity to take those 5 instances. In this video and the upcoming videos, we will talk about all of that. This video, we will focus on basic principles, basic concepts. What is Kubernetes? What are the main objects I need to deal with? In next video, we will give a more practical demo. So let's start. First concept is a cluster. What is a Kubernetes cluster? Kubernetes cluster is a set of nodes. A node is a virtual machine or a bare metal server. In this image, we see a cluster that has 3 nodes and 1 master node. The master node is the node that is responsible for controlling the others. It contains important information about the cluster, about the nodes, about how the applications are distributed on those nodes. It manages the other nodes. And the nodes are the normal servers that are available for containers to be deployed there. And then we have something called node processes. Every node, let's think about it as a virtual machine that has 2 main processes that are running all the time. One of them is Docker, because this is the runtime that will host our containers. And it has kubelet. Kubelet is a Kubernetes process that is responsible for opening a connection with the master node, taking the commands from master nodes and reporting the status to the master node, and taking commands from master to execute on this current node. So every node has a kubelet and Docker installed and running. Going back to the master nodes, a cluster may contain 1 or more master nodes as we spoke. This one has 1 master node. If this master node goes down, this means the whole cluster is down. So we generally don't deploy a 1 master node cluster. Usually a cluster contains at least 3 master nodes. So if one of them goes down, the others will stay up and the cluster will live. Let's go to the next concept, which is the pod. The pod is the building block, the main building block of Kubernetes. If I need to deploy a container, I need a pod that contains this container. So the pod is the unit. Any pod has an IP address, it can host 1 or more containers, and it has a volume. The volume is the storage that is accessible to the containers. For example, pod 1 has 1 container and has 1 IP address. Pod 2 has another IP address. It hosts 1 container and 1 volume. Pod 3 hosts 2 containers and 1 volume. In this case, the 2 containers doesn't have, each one of them don't have a separate IP address. We have 1 IP address for the pod. And both of the containers have access to the same volume. So that when they access a file system, they are both accessing the same volume. A good example would be if I have a web application, that's 1 container, that writes log to the volume, and another container that reads these logs and ship it to a database outside. I have one server. Let's say the pod is a virtual server. It's not a virtual machine. It's just a unit that has an IP, a volume or more, and container or more. So now what's the relation between those pods and the nodes? Easily, I can distribute the pods over the nodes. So the node here is one node representing one server, one virtual machine. And here I hosted the 4 pods on this node. Of course, if I have more nodes, I can redistribute those pods into the other nodes. Now let's go to the next concept, which is a replica set. What is a replica set? A replica set is a set of pods. And it's called replica because it's a list of replicated pods. I have one template for a pod and I can replicate it multiple times. If I have an application and I want Kubernetes to deploy 3 instances of this application, I'll create a replica set with 3 instances. We'll see later an alternative method that is better than the replica set, but the replica set is the basic concept of a list of pods that are deploying or hosting the same application on multiple instances. Of course, each of the pods can be hosted on different nodes. Each one has a different IP address. And the reason we have a replica set is instead of telling Kubernetes, create pod 1, pod 2, and pod 3, if I told him create a replica set, the replica set has a controller that is running all the time, trying to make sure that this replica set is in the desired state. And I told it the desired state is 3 pods. It will make sure it will keep monitoring those 3 pods. It will create those 3 pods at the beginning, and then it will keep monitoring these 3 pods. If one of them goes down, the pod will be killed automatically and another pod will be created, maybe with a different IP. So the replica set has a controller that is running all the time, trying to make sure that we are in the desired state. Okay, now I have 3 instances of my applications running in 3 different IPs. Let's say now I want to communicate to my application. I want to send a request and get a response back. Which IP shall I use? The next concept is the service. In previous world, outside of containers, we would have done this by, if I have a web application deployed on 2 servers, generally I should have a load balancer that provides me with a different IP. When I send requests to that load balancer, the load balancer will route that request to one of the servers, get me the response, and then communicate back the response to me. The service here is doing the same thing. A service is a named network object. It's just a network object. It's not a server on its own, but it has an IP. That's why it's called a network object. So in this case, we see service A has 1 pod, service B has 3 pods. Each individual pod has its own address, and the service itself has a different address. So the service here is acting as the load balancer. If I send a request to service B, it will route it to one of the 3 pods under service B. Now, how to link the service to the pods or the replica sets that contains the pods? When I create the pods, I have to use something called labels. The label is just a tag. It's just metadata that I give to the pods. A label can be any pair of key value. So in this example, we used app equal B. And in the other application, we used app equal A. So when I create service B, I'll tell Kubernetes service B needs to route to any pod that has the label app equals B. This is called label selector. So I create pods with labels, and I create service and give it a label selector that will select any pod that has a specific label. Now let's say I can manage, I create the service once and I don't have to worry about it anymore. Now when I have 3 pods with label B, if I change this replica set and I created 5 pods now, the service will automatically route to those 5. because it knows to look for the pod with that label. So the label is a powerful concept. It allows us to select pods and assign them to services. Now let's go to a higher level concept, which is deployments. We've seen a replica set, and we've seen what it can do. It can replicate my pod to multiple instances. But there are some scenarios where the replica set is falling short. For example, if I have a replica set with 3 pods that has version 1 of my application, and now I want to create version 2. Using replica sets, I have to create a new replica set that has the pod template version 2. And in this case, I will create a replica set with 3 pods. And I have to delete the original replica set with version 1. How will I do this? I can delete first and create later. I can delete replica set 1 and create replica set 2. This will give some time where the application is down. I don't have any pods running for my application until the 3 pods are up and running for replica set 2. The other way to do it is to create replica set 2 first, make sure that it's running, it's started up. Once it's complete, I can now delete replica set 1. But in this case, I need enough resources to host 6 pods at the same time. Or I can do it gradually. For example, create replica set 2 with 1 node, then scale down replica set 1 to 2 nodes, and then increase the pods in replica set 2 and decrease from replica set 1 until they're both are done. This is what a deployment does. Deployment manages the state of a replica set and make it reach the desired state gradually. It's called a rolling deployment. So I'll create one deployment. I'll give the deployment version 1, and I'll tell it, create 3 pods of this deployment. It will create gradually 1, 2, 3 pods of version 1. And then I can update this deployment. I will tell it, update the deployment to version 2. The deployment will automatically create a new replica set, and it will try to reach the desired state by making it change one by one. So it will take down 1 pod, create a new pod with version 2 in the new replica set, and keep doing that until we reach our desired state. This is powerful because the deployment keeps track of history. I can roll back a deployment. If I go to a state and I don't like it and I want to go back to the previous state, I can tell the deployment to roll back to the previous version. And it will do that automatically. The same thing, I can pause a deployment while it's rolling. I can tell it to stop. So I will have some pods running in version 1, some pods running in version 2, and when I'm ready, I can continue. Another thing is, if one thing failed during the deployment, if the first pod that I created from version 2 failed to start, the deployment will stop automatically because it cannot continue before this pod is running. So if version 2 has a problem, the deployment will stop until I fix the problem or I roll back. That's why it's always recommended to use deployment instead of using replica set directly or creating a pod directly. Let's see how our examples plays out in this diagram. I have service A and it has 1 pod and it's using a deployment. Now I updated this deployment to let it know I want 4 pods of this service. So it automatically creates 3 new pods to match the state that I desire. And in this case, it distributed them on multiple nodes. Now let's say I'll update my application to version 2. I'll update this deployment, tell it to now roll an update to this deployment with version 2. What it will start doing is, it will stop one of the pods and it will create a new pod with the new version. This is the updated app with a new IP address. Once this step is complete, it will do the same for the next pod, new IP and updated app. Once this step is complete, it will do for the rest. So as you can see, deployment is a very powerful tool to use. With that, we have seen how Kubernetes is used to manage a cluster of servers, a group of applications that are distributed on these clusters of servers, and how it acts as an orchestrator to do all of that automatically. If you like this video, please like, share, and subscribe to get notified with new videos. Thank you.